In today's lecture, we are going to study about trigonometric equations. So, all of you must have solved some equation like uh, you are given 2x plus 3 is equal to 5. So here you find the value of x. So this is here x is in the form of a linear function. So you may also be given like x square plus 2x plus 1 is equal to 9. So this is also an equation, and here x is a quadratic function. So here x is the variable and x can take different forms. Here in the first example it's taking variable x is a linear function. In the second case x is a quadratic function. So in first equation the variable x is a linear function. In the second equation x is a quadratic function, or x can take some also generic powers of x, like some polynomial function x to the power 5 or something. So x can be part of linear function, quadratic function. Similarly we can have uh, x in the form of trigonometric functions. So we have been studying trigonometric function for some time. So it may be given sine 2x is equal to 1 by 2. So in all the equations we were finding the value of x, but x was taking different functions in the different equations. So in this last one, variable x is a trigonometric function. So in this lecture we are going to study this part. So these are separate topics. So today we will study those equations where the variable x, here also we need to find x. So here x is part of a trigonometric function. So now we can give a formal definition of trigonometric equations. So equations involving trigonometric functions of a variable. So here variable is x. So this equation involves trigonometric functions of a variable. So these are called trigonometric equations. So every equation has a solution. Some equations may not have a solution, but we will study the cases where the equation is solvable. So there are two types of solutions. So one we will call principal solution, and the other one we will call general solution. So while studying the graph of trigonometric functions, we had seen that the trigonometric functions repeat itself after some, at least after 2 pi it will definitely repeat, but for some functions it will also repeat after pi. So for example we can take the case of a sine function, the simplest one. So if this axis denotes our angle x in radians, our sine function is like this. So the max value is 1. Here it's pi. Here it's 2 pi. 3 pi, 4 pi and so on. So suppose we are asked solve this equation where sin x is half. So we had studied sin 30 or sin pi by 6 is half. So this will be pi by 2 and half is somewhere here. So at this point it's half at this value. But you see that here also it's the same value. So in 0 to 2 pi we will have two such values, pi by 6 and this pi minus pi by 6, because we know that sin pi minus x is same as sin x. But if we take sin 2 pi minus x, then it will be minus of sin x, or sin pi plus x, then also it will be minus sin x. So if pi by 6 is a solution, then pi minus pi by 6, which is 5 pi by 6, this is also a solution. And we are exactly see that from this diagram. So here it's the first point is pi by 6, second is 5 pi by 6. And if we go beyond this 2 pi, then again we will get more solutions and we will get infinite solutions. So after 4 pi we will again get, so in every 2 pi range we have two solutions. So this has infinite number of solutions. So this principal solution, so the solution in the range whereas x is from 0 to 2 pi, we will call principal solution, and general solution we will be representing the entire solution. So it has infinite solution, but we can generalize it in the form of some integer n. So we can write in the form of some function of pi n n, where n is an integer. So these two are our principal solutions. So if we are asked find the principal solutions of sin x equal to 1 by 2, we will say that it's x equal to pi by 6 and x equal to 5 pi by 6. Now we will see how to find the general solution. So principal solution is very straightforward. In order to find general solution, we will prove some theorems and we will use those theorems to find the general solution of any trigonometric equation. So our first 3 because we can have either in terms of sine, cos or tan or their inverses. So we can express our trigonometric equation in the form of one of these three and we will get the general solution. So first is that if sin x is equal to sin y, where x, y are real numbers. So if we are given two real numbers x and y and sin x is equal to sin y, uh, then we have to find the relation between x and y. So we see that if x is this pi by 6 and we are said that y is some other value or same value, y is some other angle for which it's again equal to half, then we can say that y may be pi by 6, y may be 5 pi by 6, y may be this 2 pi plus pi by 6 and again. So y and x can be related and we can write that relation. So if sin x is equal to sin y, then so here n belongs to the set of integers. So if sin x is equal to sin y, it may not be that x is equal to y. There are multiple scenarios. So if we put n is equal to 1, we will get, if we put n equal to 0, we will get this first term 0 and second term y. So if n is equal to 1, then x equal to y. If n is equal to, if n is 0, then we will get x equal to y. If n is 1, then we will get pi minus y. So here exactly for n equal to 0, both x and y will be here. For n is equal to 1, y will be here, pi minus pi by 3, pi minus x. And again for n is equal to 2, it will be here. For n equal to 3, this value. So we will get all the possible values of y for which this sin x is equal to half. So here if sin x is equal to sin y, then we will prove that x and y are related using this form. And this formula will be very useful in solving the general solutions of any equation. So we are given sin x is equal to sin y. So this we are given. So we can write it as, we will bring sin y to the left hand side and we can write as sin x minus sin y is equal to 0. And in our previous lectures we had studied what's the formula for sin x minus y, sin y. So it will be 2 times cos x plus y by 2 and sin x minus y by 2. Now here the product of two numbers is 0. So either one of them or both has to be 0. If one of these is 0, then their product is 0, or both are 0, then also product is 0. So from this we can say that x plus y by 2, this is equal to 0, or this is equal to 0. And we had also seen that if cos x is equal to 0, then x has to be some odd multiple of pi by 2. So cos pi by 2 is 0, cos 3 pi by 2 is 0, 5 pi by 2 is 0, 7 pi by 2 is 0, but odd multiples of pi by 2 will not, even multiples of pi by 2 will not be 0, because cos 0 is 1, cos pi, which is 2 times pi by 2, is minus 1. So this implies cos x is equal to 0 implies x is equal to 2n plus 1 pi by 2. So for all the odd multiples of pi by 2, cos x is 0, and sin x is 0 when x is 0, pi, 2 pi, so all the multiples of pi. So this implies x is equal to n pi. So in both these cases n is an integer. So this thing we know. So from this first part, this x plus y by 2, this has to be an odd multiple of pi by 2. So this comes from the first part, and from this part we get x minus y by 2 is a multiple of pi. So we can cancel these two. So what is x here? X is 2n plus 1 pi, and y comes to this side, right hand side, and the second part is x is equal to, so 2 comes multiplies here, so it becomes 2n pi, and plus y. So x is either 2n plus pi minus y, uh, here is some typo. Now we will try to combine these these two into one. These two expressions we will try to combine into one. So so we will rewrite the first case. So we see that if we have odd multiple of pi, so x is either odd multiple of pi minus y or even multiple of pi plus y. So x is either odd multiple of pi. So if odd multiple of pi is there, y becomes minus. So minus 1 raised to the power some odd number is minus 1. So we have to find the similarity between these two expressions, or some even number times y pi and minus 1 raised to the some even number. So even power of minus 1 will be plus 1. So we have found the similarity between these two expressions. So if odd multiple of pi is there, then we have minus 1 to the power odd times y, and if even multiple of pi is there, then we have minus 1 to the power even times y. So this step we will not write, it's rough work. So we can write, so if suppose k is a number, then we can write k pi plus minus 1 to the power ky. So here we have, if k is odd number, then also we will get this, that k pi plus minus 1 to the power ky, or if k is even, so we can generalize this now. N pi plus minus 1 to the power ny. So why this is true? So n can be either odd or even. If n belongs to integers, then n can be either odd or even. So if n is odd, this value will become odd times pi plus minus 1 to the power odd y, and if n is even, then we will get this thing. So we have proved this formula, sin x equal to sin y. If sin x is equal to sin y, then x is equal to n pi plus minus 1 to the power n y. So we could have also written, in place of this, we could have written x is equal to, the general term for odd is 2n plus 1, 2n plus 1 pi plus minus 1 to the power 2n plus 1 y, and similarly this term, in place of even we will write 2n. So this formula we need to remember. If sin x is equal to sin y, then x and y are related with this formula. Similarly, we will see the case for cos x and tan x, and then we will see some examples where we will use these formula. So if cos x is equal to cos y, again x and y belong to real numbers. Then so we will prove this. So similar to our earlier first example, we will write cos x minus cos y is equal to 0, and we will use the formula for cos x minus cos y. So either this thing or the second term, one of the two terms has to be 0. So from the first part we will get and from second part so x is equal to 2n pi minus y or x is equal to 2n pi plus y. So we can combine this to write x is equal to 2n pi plus minus y. So again here x, y, these belong to real numbers, and n belongs to the set of integers. So this is understood. So for this case we have proved that x and y are related by this equation. So this also we should remember, and this was the first case. Now the last one is tan x is equal to tan y. So similar to our earlier proofs, we will write tan x minus tan y is equal to 0. And we will write tan in terms of sine divided by cos. So it will be sine x divided by cos x minus sine y divided by cos y is equal to 0. And we will take the LCM. So it will be cos x cos y and first term becomes sin x cos y minus cos x sin y. This is equal to 0. So we will take this cos x cos y to the right hand side. So then that will become 0. And in the left hand side we will have this numerator term. So sin x cos y minus cos x sin y. This is the expansion of sin x minus y. Is equal to 0. So if sin x is 0, we know that x is some multiple of pi. So here x minus y is some multiple of pi. Or x is equal to n pi plus y. So we have proved this part. Now we will see examples where we can use this. So I will take one example for each sine, cos and tan, and in the next lecture we will see more examples. So first question, let's say we are given sin x is equal to minus 1 by 2. So this we are given. So we know that sine pi by 6 is half. So in place of half we will write sine pi by 6. So it's still not in this form. So we need this form sine x is equal to sine y. Here we are getting minus sine pi by 6. So this is y pi by 6. This is, we have to remove this minus sign. So we can write it as pi plus, we know that sine pi plus theta is equal to minus sine theta. If we write pi minus x, then it will be same as sine x. But if we write Sine pi plus pi by 6 will be equal to minus sine pi by 6, or sin x, and right hand side pi plus pi by 6 is 7 pi by 6. So now we have this form, sin x is equal to sin y. Then we will directly use this formula to get the value of x. So this will give the general solution. N pi plus minus 1 to the power ny. So x is equal to, so we were asked to find the value of variable x. So in all the equations our target is to find the unknown variable x. So x is equal to n pi plus minus 1 to the power n y. So here y is equal to 7 pi by 6. So this is our general solution. So here we are asked to find general solution. If we are asked to find the principal solution, then we will find all the values of x between the range 0 to 2 pi. So, all the principal solutions are also included in this general solution. So what are the principal solutions? So if this is our sine function between 0 to 2 pi, then minus half will be here, pi plus pi by 6, and 2 pi minus pi by 6. So 7 pi by 6, and this second one is 2 pi minus pi by 6. So 12 minus 11 pi by 6. So these two are the principal solutions, and this one is the general solution. Now we will see second example of cos function. So this was sine function. So we are just seeing some simple straightforward equations. In the next class we will see some more involved examples. So we are given cos x is equal to half so find again general solution, or it may also be written as like solve this equation. So we can write cos x is equal to, and we know that cos 60 degrees half, so we can write cos pi by 3. So cos x is equal to cos pi by 3. So now we will use this formula. So if cos x is equal to cos y, then x and y are, then x is equal to 2n pi plus minus y. So here x is equal to 2n pi plus minus pi by 3. So this is the general solution. If principal solution is asked, we will only give two values of x between 0 and 2 pi. Now we will see the third example for the tan functions. So we are asked to solve this equation. So this we are given. So we can write this. So tan pi by 2 plus x is equal to minus cot x. So we can write it in terms of tan x. So our target while solving these trigonometric equations is to bring both left hand side and right hand side. So here it's cos x and again cos of some other number. Here also we sin x and then sine of some other number. So we have to bring it in one of these three forms. So here we will convert this cot to tan. Or we can simplify this further. So tan x plus 3 times 2 6 and 3 plus 2 5, so 5 pi by 6. So now we can use this formula. If tan x is equal to tan y, then x equal to n pi plus y. So here left hand side is 2x, so 2x equal to n pi plus y. N pi plus y is this term x plus 5 pi by 6. So x comes this side, left hand side, and it becomes 2x minus x is equal to x, and right hand side is n pi plus 5 pi by 6. So in all the places we have to write that n belong to the set of integers. So here also we will write n. So this is our general solution. So these were simple cases. We will see more examples in the next lecture. Thanks for watching.